Hello, folks. What is wrong with me that I'm back here streaming again? I don't know. Something. This is pretty cool. 19 bill steps already. We'll see if that does anything. Cool, we're in the right box. Okay. What to do next, man? What to do next? Let's just take a second and think. Puffer lib is kind of good. Nuance, kind of fine. Models, pretty okay. Bindings are bindings. Of all of this, the only stuff I'm really annoyed with was, well, Ocean, but Ocean's like the one end, whatever. And, like the struct kernels thing. I mean, it's the evening, we can kind of chill and just think about stuff a little slower now. I think that's reasonable. That's reasonable enough. This is cool. Hey, Liberty. I'm doing pretty well. We've already streamed a ton today, but I'll figure out a few more things while I'm here. I guess I don't like that we have this just massive blob of crap in kernels.cu and then we have like pulled stuff out into structs.h. Too many small files as well. This is core network stuff. The first 400 lines. we have another 300 lines of PPO, loss, 200 lines of logic sampling, 100 lines of copies, 100 lines of miscellaneous, buffer for like buffer ops, and then the advantage, some generic kernels, many of which only get used once. For some reason, we have an allocator in here. Buffer registration, I don't know why the hell this is here. Blast. This is the dirtiest part of the whole thing at the moment. Liberty. Simulator for Age of Empires and that's a big project. You're going to want to think about, well, you're going to want to look at some of our materials on how we make our sims fast. You're going to want to think about the observation and action spaces, how to prevent stuff in a compact, reasonable form, and minimize the network complexity. Those are probably the main things. And some actual generic terms. And holy PPO, right? Freaking thing here. So now knowing what's in here, does this help me at all? I don't like the idea of having this be a million files. I also don't like the idea of just dumping all the crap in here. Five new files? Hell no. We're gonna do some experimental stuff. Opus now. Did they update it? They don't put their pricing on here, which is kind of funny of them, isn't it? I think I'm fine with puffer lip CU being longer. I think. I mean, ultimately, the best thing is to just reduce the total amount of code. At least this puts the relatively clean sections of code back into here. These are nice buffers, right? This is actually kind of useful stuff to have. What else is in here that shouldn't be in here? These kernels can go here. This is fine by me. Actually, this is now... There's not that much weird shit in here anymore. Except the allocator. Oh no, we still have kubeless matmols. No, we still have actually a few hundred lines worth of weird shit in here. If this file ended up about here, 1300. Interesting. I don't like having structs like this is the thing. I don't think that this is actually a good way to do it. But let's see if this runs. Okay, that still works. How much code is this? Do we have any hope of eating the kernels file? Hmm. There shouldn't be a file named kernels, is the thing. It really shouldn't. I'm trying to think of like the different ways that I could put this together. I mean, I may as well try some stuff, right? Let's think about this. I'm gonna like try this out, and then y'all can tell me whether you think this structure is better. So just having a massive ass kernels file. It's already a third gone. Utils files suck. We're gonna make one for now though. Are we? Really don't want a stupid utils file. We'll do it for now. No, because they're gonna have to import each other, aren't they? Fuck. What else we got here? Soft plus. These should just go. So this is the thing that's shitty. Well, this is no longer hiding complexity. This is in line with the philosophy. Only have 680 lines left in here. A lot of this can even be cut more. It's like this is all, right? All this stuff. How much do we have left in here? Not that much. Hey, Muffin. How's it going, man? I checked your DM. I got completely spammed by, like a bunch of crazies with some good artists in there. That was a really weird website you sent me. I don't know what to make of it. Finally got your PC? You're doing some RL then, yeah? Non-stop RL? Oh man. That'd be good. That will be good. I'm just trying to figure out. I'm playing around with the puffer 4 code now to see how I like it split up. It's about 5,000 lines of CUDA and CUDA C. We only have 450 lines left in here, and most of it is like fiddly little kernels, right? Oh, I pay for stuff for sure, man. I definitely pay. That's not an issue. It's mostly with the buffer. The thing is, it's a fair bit of work, and it's like 3D character. So it's low poly. It's character work, so the actual like expression and feel of it has to work out. Um, there's rigging and animation with it. It's probably, let me think. No, it's probably a bit simpler than making like the character model, like and animations and rigging for an indie game. But it's probably not that much simpler, right? Yeah, it's a little bit simpler. It doesn't have that many animations. Let me see if I gotta be careful loading too many of these because, okay, not this dude. Not this dude. I mean, I could go through. I had a list of people who I thought were like decent. Have you seen the latest perf numbers, Muffin? Very small models, 20 million step per second training. We've got multi-GPU on Neural MMO, close to 4 million steps on the tiny box. It's 50% faster than 3.0. We got about 15 or so mil for like your standard architecture for most problems. Some pretty good stuff in here. I wish I had like, some of these kernels are just really bad. What about all these operations? Like, I'm trying to think if there still needs to be like an ops file or whatever. Probably don't want to have a pufferlib.cu, right? Practice, yeah, 4.0 is going to be crazy. I mean, I can send the model files. I can send the specs. But like, I don't want somebody. I don't want to like be having to say, "Oh yeah, like start it, and if you do it, it's good. Like, and it's good, I'll pay for it." Um, because it is a valuable enough job. Like the plan is that this is probably like between a $2,000 and $4,000 job. Um, I will go put up the model files together, and if you message me, I can like I'll make them available if you want. And I mean, obviously, if it's good, I'll just say, "Oh, perfect, yeah, just hire her." Um, the thing that I want to avoid, like, I mean, the feel of it is very important, right? If I can get something where I have the puffer swimming around in a little demo, and it actually feels like good, like it feels like a real character, then we're set. Drop it on Discord and I'll grab it. Okay. I have to put all the stuff together, Muffin, and I probably have to spend a couple hours to like, load the current version in and make sure the animation format is good so that artists can just drop their animation files in and then like see if it works correctly. So I have to do a little bit of work for that. That might be like I have stuff to do this weekend, but that'll probably be like a chill stream day project for me to do. Quite soon though, because the release is getting there. Release is getting there. So the difficulty I'm having here with this is does it make sense to have a generic ops file where we try to have like really high quality implementation of various operations? I don't think so. Because what ends up happening, right, is you end up needing to just use the code from those directly. Like the whole min group, for instance. Like stuff like this. Yeah, I don't like stuff like this at all. But then stuff like this, this makes sense to have. And guess what? Then the Kai Ming in it would go in models. like that. Yeah, I don't like this because this is just torch all over again, right? I don't even really like this. Man, I hate wrapping stuff, but then like when they have all these freaking extra arguments, well, let's just see what we can get rid of from here, actually. Let's just start with that. Let's see how small this gets. A lot of these are just like different source and density types. Just normal function overloading. And why is global? Okay, so this is call from either. Doesn't really need to be marked global, does it? Yeah, that's really screwy. Hmm. Cast to precision. F32 to precision. Let's see if this runs. It's a heck of a slog, Jess. We're getting there. Wait, I'm confused. Host. So you can call that's annoying. Well, that's not bad, right? I think I can still do it. No, wait, it's sketchy now, isn't it? Does this not work? No, this is not what we want. Just not do this. Think how we want to do it. Interesting. Okay, let's see if this works. I'm kind of curious. So I think this should. Ops is a little wonky. Hmm. Quite weird. Let's see if this remotely works. No. Lovely. Not at all. Of course not. Very annoying. Let's just do puffcast. I think this is good. This will do it. probably this crap, right? Yeah, this is so shitty. How the fuck do you do this and not have it be just disgusting? We met Chelsea Finn? Maybe? I'm trying to remember if she was there when I was still at Stanford. Ugh, that's disgusting. I don't like any of that shit, that's awful. It'd be better to just do it like not shit, right? So what, you just do like this, right? do. Gets rid of some cast crap, right? Oh yeah, I'm heading out in I think like 20-ish minutes. We'll call it for the evening. Gotta wind down a little bit. For the folks here though, I will be probably streaming a decent bit tomorrow. I also have to talk with Spencer some. He might stream the onboarding, we'll see. It could be fun. Delete these. I mean, this is not... If we get to delete all of this, we get to just delete all that. It's actually really nice. It works this way. I mean, if this lets us get rid of all that crap cast logic, like, I don't think this is the best thing, but this is closer. Right? Hey, Luke. Oh man, so much work, but we're making progress. We got 20 mil SPS small nets, 15 mil reasonable nets. We've got stable multi-GPU, we got sweeps, and we got the new architecture nice and working. Mostly just some cleanups now. Quite difficult to get this clean. This is on my local low-end machine here, these stats. Yeah. Hello, Kaiser, welcome. That deletes a whole bunch of crap. Is this just not used? I'm confused. I thought this is used. What? Oh, dummy, it's used right here. Let's see if this is good. -1 function. What else do we still have in here? Okay, not too much left in here, right? We're gonna have to rethink our types most likely. It's kind of just C that runs on your GPU. Doesn't have to be magic. Doesn't have to be complicated at all either. I actually wonder if we should allow if we should just have a single tensor type, or if we just have, you know, like float tensor, this tensor, that tensor. Because doesn't that fix it immediately? Well, I guess you get the blow up on it, don't you? It still blows up. number of implementations. That's annoying. What other stuff can we get out of here for now? Some rows to precision. Subscribe, thank you. It's all open source. If you'd like to check it out, it's on puffer.ai. If you really want to help me out for free, start the repo on GitHub. It's the fastest growing, highest performance RL library out there. And we have tons of demos on puffer.ai. They run agents in your browser, and you can train that at home because it's just that fast. A lot easier to get into than you'd expect as well. You kind of need this. Oh, this is for just continuous crap. Unclear. Thank you very much. Puffer like stars. Puffer very hungry. Decoder grad kernel. This doesn't go in here, right? I bet you we can just probably stick this thing in here. Yeah. Hang on, can't we just do... Problem is I don't want to pollute this section either. I'm just going to stick this here for now. And I gotta run pretty soon today. I think I'll be streaming more tomorrow. It depends how long stuff takes with Spencer. The goal is to get him onboarded to all this. And he can help me make sense of all this crap. Hello, welcome. How's it going? Like, this looks like a general kernel, but it's really not. Right? If I just go put this where it belongs, which is like here-ish. Let's go down. Okay, so here we can actually just go take this, put it where it belongs. Now this is basically pretty minimal. This shouldn't be kernels or whatever. This is the bottom. I don't know where this should go. Try out Opus. That was awful, man. That was awful. I think I've been proven right in some sense that it's just the death of reason. Because since then, I've seen like several people I used to respect basically just go off the deep end and are now like not producing anything of value anymore. They like retired from thinking. Oh, this is one thing we can do. This is one thing we can have this do actually real quick. Easy to connect this to buffer in order to do RL to AI. Yeah, the only thing that's a little iffy is because board games are turn-based. There's a little extra stuff for turn-based that's going into Puffer 4, but we have a project for that with Jess and Spencer They've been working on a really cool chess project around that. So yeah, you just look at. It seems a little sparse. Any good resources how to add my game? No, there's a tutorial for this. This is the one thing that actually is on the docs. So right here, like these are links. We got a template environment. We have a couple demo environments. They're nicely commented. This is a single player template, for instance. Well, we got target, we got template, we've got a couple others. Target, template. Just commented minimal environment. There's the target environment, which is a minimal multi-agent environment. That's pretty much all you need to get started. For the turn-based thing, like, oh, how do I make it turn-based self-play? Like, give it a random opponent to start, make sure that that works, and then go ask Jess for that. That would be a good way. The code quality is going to vary since they're by different contributors. The basic, sure, you can use that. So Go and Connect 4 versus like scripted opponents at the moment. They're not full self-play. For full self-play, we have the chess project. I think ours is at like 1300 something ELO. That's no search though, so 1300 ELO, pure RL self-play with no search is pretty cool already. You can ask Jess for that, but yeah, I would basically just give it a random scripted opponent to start. Make sure you can beat your scripted opponent, you get the integration, and then ask them on the self-play integrations. Yeah, let's get rid of this. We don't want that stupid C++ feature. There we go. Raw pointer's better. When I do it in Kaiming as well. Okay. No, I don't think it would be worth waiting for Puffer 4. Like, it's already the highest performance thing out there by a huge, huge margin. And, like, anywhere else you're going to go is just going to be... I don't think it's going to be any easier, first of all. Like, RL tools in general are very, very bloated at the moment. So, you know, while we don't have perfect everything for turn-based stuff at the like in Puffer 3, what we do have is quite compact, very fast, and very simple. And we have people like actively doing turn-based stuff in a variety of different projects as well. They make relatively small changes to the code base to support it. I guess it depends what you're coming from, like what library you're using at the moment for this. Hey Mystic, yeah, just for a little bit. I'm gonna go take call soon, so I'm almost done for the night. Thanks, Joe. Yeah, no worries. Got this. I keep finding all these C++isms all over the place. I really want this to be just like coup to C, you know, very, very minimal. Nothing to RL. Yeah, start here then. Puffer is good for this. Just the speed that Puffer gives you lets you just do things instantly that take literal days otherwise. And we have a very large emphasis on simplicity. So Puffer 3 is just straight simple, no gotchas. Puffer 4, I will admit, is going to be moderately more complex. But the reason that Puffer 4 is complex is because it doesn't use, well, the highest perf backend, there is still a torch option, but the highest perf backend in Puffer 4 doesn't use torch. So, like, if you look at it as a whole, it's like 1/10 of the complexity or less of torch, but there's no torch. So, like, if you're considering torch as 0 complexity, then yeah, it's more complicated. But if you're considering, like, oh, torch internals are weird and I always get confused with stuff whenever I try to do anything custom, then it's way simpler. I don't know. That's probably more information than you need for now. It's fast. There's a big community to help you out. It's a great way to learn RL, both at a high level, but also all the way down to the systems level as well. And it's used in a bunch of things, and it's growing fast. So there you go. And I'm here slaving away trying to get this thing to actually be reasonable. This shouldn't break it, right? This is like a literal IDE syntax refactor op. I just don't like the ampersand syntax, the C++ ampersand syntax. I find it redundant and confusing. Or is it magnitude faster? Yeah. It's kind of funny because every time somebody ends up claiming that they have something like faster than Puffer or anywhere near as fast as Puffer, it always ends up being fake. We had one of those today. That was pretty funny. Oh yeah, this is a breakout in like 8 seconds on my low end machine. Um, we can get to 4-second full solves on the higher end machine. If you need to just be sold on the speed. If that's was a question. We can fold this, right? I think it's just a little too long. Yeah, that's nice. And then fold this one, of course. Yeah, I like the way this looks. Nice gems. Okay, I think this is a reasonable spot for the day. Thoughts on getting PhD? I never suggest people get a PhD. You get a PhD if you know you want to get a PhD. Like, I knew I needed a PhD because I needed to work on a crazy thing for 5 years. And, like, I still was just straight up not having a good time for a lot of it with a supportive advisor at a top school. Like, you need to know what you're signing yourself up for. I don't think I know anybody that's just like, oh yeah, PhD is great. I mean, did it set me up to do all this stuff quite well? Yeah. I could have probably done a lot of things much more efficiently though. on good work. I'm trying. It's tough. Oh, that's fine. It says I only deleted a couple lines of code after all that work. I think I added better spacing though. See, this is why line count is a bad metric. You actually need some sort of reasonable tokenization to know whether you're going in the right direction. With Dan on YouTube. Oh yeah. I had, what was it? I did like a talk for beginners with University of Warwick. That's on my YouTube as well. I think that's the most recent one I posted. That was a decent little talk. Let's merge this thing. I'm sick of working on this static native branch. This is dumb. Let's just have this be 4.0. We're obviously not going back to pure torch at this point. Oh my gosh, GitHub. You go to 4.0. Oh, it's minus code. That's cool. I hate that it's merged source branch into target branch. Like this always does it backwards, right? I don't want to mess it up. Whatever, we'll do it this way. Fucking GitHub, man. I really do not enjoy this. Why? What the fuck is this? Control M at the end of everything. Huh? Created on a Windows or DOS system is open. What the fuck has this done to my code? I hate this. Can you do that? You can't, right? Because it's a control character. Yeah, no, this doesn't match it, dude. Because it's not actually a caret. There aren't even meaningful changes in here, are there? There literally aren't meaningful changes. Because I merged these both. Okay. Hang on, we'll just... This is annoying as fuck. Let's do this. Oh, actual control M. I see. That's probably... Yeah, okay. I didn't realize you could do that. No, dude, because that enters. Whatever. You're doing a... No, I am. Percent S slash... Yeah, it enters immediately, dude. I don't even know how the fuck this happened, because nobody's editing this shit on Windows. This is like GitHub doing some utterly cursed stuff. I wonder if it's gonna try to like strip all the frickin'. This is fine. There are no meaningful changes though, because like I already had done this, so I don't even know how this ended up being like registering as a merge, as a conflict. Stupid bullshit, man. That worked. Nice. Now we have it on 4.0 proper. And it shows stats for the main branch, not the latest. It's a little annoying. Handwriting code for the most part. Get rid of this crap. Let's see if this works. $12 mil SPS with the small net on my local not so great machine. A little bit of RNG on the return there. It's just hypers, don't worry about that. And let's see. Oh. Huh. Okay. We build on 4.0. We're just making sure we didn't merge it wrong. And then we'll show the line counts and everything in a second. So this should be bitwise, this should be like perfectly bitwise deterministic. Okay, it isn't somehow, I have no idea, but wait, no, it is 071, that's the same. Perfect, we're good. We're good. Let's check on our big run. We're still alive. GPUs are not on perfect utilization, oddly enough. Not perfect. We are at 1.5 score with 50 billion steps. Not ideal. It's something though. We'll see where it goes. It's only been live 3 hours, 38 minutes. I will let this run overnight. And we'll see what this gives us. I set this one to give us, this one should give us a whole bunch of points, essentially. It's not going to downsample this one super far. So we have Puffer Breakout, Puffer Neural MMO that was, of course. Oh yeah, I said I'd do the word counts for everyone, right? So the current Puffer lib 4.0. Really, the actual training code is all here in source, all right? So you can take PufferNet out of this because PufferNet, this is only used for our web demos. I should probably move it somewhere else. So minus this, we're just under 5,000 lines of code for the new backend. I don't know whether I like this number of files. 400 lines of bindings, 180 lines. This is for the cuDNN binding to support convolutions. 349 lines of like kind of shared, used in several places kernel ops. I think we can get this down to maybe 250. 847 lines for models. I believe that's about 400 lines of like C code for the models themselves and 400 lines of kernels. 232 lines for the entirety of Muon, including its kernels. Not bad. Ocean, 318 lines. This is just the janky neural MMO encoder. This is not cleaned up at all. We'll come back to this one. 186 lines of structs. I don't really like to have my struct split out into a file like this. I haven't figured out what I want to do with this yet. And 600 lines for the vectors that can probably be cut down to 500. And then the big one is pufferlib.cu. I believe half of this file is the actual setup for the training, CUDA graphing, buffer registration, all of that stuff. And about half of this is devoted to custom kernels. Those custom kernels, a couple of them are very poorly written. I think overall, with a little bit of assistance from some people in the community who have some kernel dev experience, I think we could quite reasonably get this down to 4,500 lines for Puffer 4. I think with a lot more effort, we could potentially get it down to around 4,000 lines. But it's fairly compact. This is not like horrendously awful bloated at this point. So that is some major progress for today. I think I have a few minutes left. I'm waiting on somebody here. But for folks who are new around here, I stream all the dev on this several days a week. Probably going to be more days of the week. Once I'm back to the farm where I stream from. Been in Florida for the winter. If you want to help me out for free, start the Puffer on GitHub. Helps me out a lot. You can join the Discord, discord.gg/puffer to get involved. And you can follow me on my new X handle. They gave me a nice shiny new one here, Suarez, for all the RL content. You get to see things like, oh, the fancy new result that was reported today is not actually a thing. All right. What now? We can think about a couple last things for tonight, because I am going to be able to do a little bit of refactoring tomorrow as well. The only major uncertain thing I think left with Puffer is just getting the neural MMO nets to produce a good policy. That's it there. There's some stuff to test, but even anything that's broken is relatively quick to fix. There's some Python updates to do. Those are easy, no big deal. Structure-wise, I don't really like the idea of shipping. I think the PPO kernel is really bad. And a couple of sample kernels. Like this section of the code here, this is clean. This is clean. Very clean, in fact. This is all just nice, mostly C. And then we get down to the kernels, and we have stuff like this sample logic kernel, which is just a complete disaster. And then we get down to the PPO kernels, which are like an even more insane disaster, like 400 lines worth of stuff to compute the PPO loss. This is just disgusting. And then these gigantic structs worth of data for PPO. And then gigantic kernels for computing prioritized replay, which is like 3 lines of code normally. But then if we actually get away from all that crap, all the kernel stuff, and we look at the train loop's pretty clean. We transpose a whole bunch of things because the buffers need to be flipped in memory. And then here's the train loop. It's like, what, a screen or two of code? It's like 2 screens. Here is your policy forward, PPO loss, muon step, and that's it. Some really nice profiling tools in here. I got the create function to not be totally insane now. So it's a big struct with a bunch of functions on it. But it's just one code path. Here's registering. This is basically allocating all the memory used in the entirety of training. That's it. And here's the CUDA graphing section. We eliminate all the overhead from launch calls. A couple very small things I'm not happy about in there. I think the really big one is those kernels just sucking. So I mean, in that case, like, aside from neural MMO, it's really just what do we do with these 2 little files, like the structs and the kernels file, total 500 lines. This has like this stuff in it. Oh, you know what? I bet you we don't use these all over the place anymore, do we? Wait, do we pass these? What do these things need now? These things take allocations. Encoder waits. No, they don't take rollout buffers anymore. So wait, can I just like, if I take these things, can I just paste these? If I delete these, and I paste them at the top, does this work? Obviously, this is not the idea of what to do here, right? I think that since we've moved all that crap out of kernels, apparently prefix scan is still used. I have no idea what C++ all this is. Okay, let's put prefix scan back. Wait, but maybe it just goes in models. Wait, hang on. Does this just go here? Maybe this just goes here. Ooh, okay, that does just go there. So I was just kind of stupid with the way I had it organized before, yeah. I think this is way better. What's left in structs? Like nothing, right? Yeah, this the quickest way to just delete. We'll just delete this and see where we are missing it. Oh, this is literally just bindings? No? It's needed in here as well, in buffer lib. That's actually not bad though. So now we're literally just left with the allocator struct and the puff tensor struct, which I don't know what to do with these. So they definitely don't go in kernels, but I'm just going to stick them in kernels for now because I don't know what to do with them. And puff tensor will go at the top. This is the only thing that we might keep as a struct with methods. We might. To be determined. I'll stick this here. -1 file. And this still trans. How long is everything? That's bitwise identical as well. Okay, buffer lib gets a little longer. 430 lines in kernel. And we got one file to deal with. Do we just like name this something else and then just figure out what doesn't need to be in here? Honestly, I think probably almost everything in here needs to either be in here or be deleted. The timing in it, yeah, frankly, even that's fine there. Okay, this is no longer kernels.cu, obviously. I don't even know what the heck this is. It's just a shared file, right? It's all standalone. Hey, we're on the same page. Hello. I can definitely put some effort into deleting a couple of these functions. Under 5K lines. It shouldn't freaking be called kernels.cu. If you're having difficulty naming it, you're probably doing something wrong is the problem. The thing is, it is just utils. Or shared. I don't want to go stick like the allocator into allocator.cu and have that be freaking 20 lines, and then go stick kublas, right? And then like have that be 20 lines or whatever. Yeah, I'm too tired to think of that. I'm too tired to think about that. Let me see if there's what else do we have here to look at. I guess the remaining bits would just be like, can we reduce the size of the giant ass kernels, right? We have 800 lines of them or so in pufferlib.cu. 900. We could think about the tensor structure. Showing burnout for today. Yeah, I'll be done shortly. Today's been a damn good day though of work. What is 10 p.m.? 10:30. I've started around 10. I took like a short break for dinner. It was probably a solid 12 hours worth of dev today with everything included, plus an hour's worth of other stuff I did in the morning. Very good progress, I'd say, on the refactor. There are a couple of things I'm not fully certain about structurally, but then most of the stuff that's really jank is just isolated to some of the kernels being shitty. Anybody who's had a few months worth of kernel dev experience could help with those, though. It's not that hard. I guess the only question I'm not sure, do we want to have, do we just have like one tensor, or do we do it by type, right? Do we have like a float tensor, char tensor, like, do you have tensors per type? If I do it per type, I don't have the weird size tracking. I avoid a whole bunch of weird casts, I think. The trick there is that I end up using function overloading. It's arguably much safer. I think this is one of those things I'm just gonna have to take a couple hours tomorrow or whenever and like try it and see if it looks better or not. So the issue, let me explain why I'm considering this. You can't just have the type, like there isn't a type T in C, right? You can't just have the type be dynamic. So let me show you how this is weird. Ignore the fact that we have all this stuff hanging off of puff tensor. Just look at these three fields. Bytes, okay. Shape, okay. D-type size. So you either have to give it D-type size or just give it a D-type enum. The enum can't be the type though, right? And then you have to do conditional logic on the enum to find out the size or find out whatever else. Where I was thinking if I do like, first of all, it shouldn't be a puff tensor, right? We can call it float tensor, char tensor, precision tensor, like BF, B float tensor, whatever the heck we want. And then the trick here would be the trick here with this is that if I do that, I can probably make the kernels themselves just take the tensor values. Like this could be float tensor, or whatever. And I can just like define several versions for the different tensor types and stuff. And it'll call the correct one for you because you get function overloading. To be fair, I could also just decide I do it manually and just add float, add whatever, and still name them and not use the function overloading, but I'd have that option. The cool thing with that is then I wouldn't have to cast every time. I wouldn't have to cast from char star. The cast is kind of sketchy. I think you might even be able to do, I might even be able to make it a host method for like add, puff add or whatever, that takes the types. That's still less sketchy. I think it's worth investigating that tomorrow. All right, so we have that one thing to investigate. We know that there's still a couple things to do with the structure in here. We know that these frickin' kernels in pufferlibcu suck. Some of our kernels are quite good, but there are a couple in there that just suck. That's nothing. And then, yeah, the only question is just neural MMO. One 1.6. Can I find my old curves, I wonder, for this? I mean, let me see if I can find them. I don't even know if Neptune is still a thing. Yeah, literally the Neptune.ai redirects to OpenAI now. So it's just gone. So I don't even get my experiments. Yeah, yeah, OpenAI bought and killed the thing, lo and behold. I still have the curve somewhere, don't I? I'm sure I have the curve somewhere. They're probably on. Do I not have an article with these? Oh yeah, here we go. Oh, there's no x-axis on this. Is that a Neptune plot or a 1B plot? I think that's Neptune. It's so much faster than this now is the funny thing. Yep, this is the correct approach. See, now I'm a little concerned because now I have to figure out why. I guess should be home by now. Could be the learning rate doesn't perfectly transfer. Four layers. Five 12 hidden. That should be the correct size. Gamma J lambda. May as well go check a couple things while I wait. Okay, default config. Let's see if any of our defaults changed in an important way. So learning rate. Clip coefficient. Value function. Mini batch, but I think we have this custom. Vtrace. Betas. Mini batch size. Okay. So and then these are all getting multiplied by 4 or by 6. Yeah, these are all the same. Dang. Only difference I know is that we don't have the layer norm kernel, which sucks. Oh, they're 40 levels. Interesting. Could be a bug in the policy. We'll have to go test it more carefully. We'll at least get to see what this does. Does this not mask rewards? It does. It resets here, right? Oh, but you know what? I don't know. I don't know. I think there might be a thing. I'm gonna add this to the frickin' end level. It's such a common bug. So it gets a double death. Okay, we'll patch that and we'll see. I don't think it's worth. Is it worth zeroing this? I think it probably is. Let's fix this real quick. Okay. I gotta go, people. I'm getting a call. I will see you all later. Start